So first, you have to understand what is the definition of externality, right? So basically, if there is this uncompensated impact of one person's actions on the well-being of a third party, a bystander, in this case, we would say there is externality. And of course, depending on whether this external impact is positive or negative, we will have positive externality and negative externality. And we started first with this negative externality. For negative externality, we used this example of pollution. And we learned that under this negative externality, the competitive market will produce a quantity which is higher than the socially optimum quantity, right? You can see this on this picture here. That is, the quantity produced by the market is too high, is inefficiently high. And then we did some welfare analysis, and we find out there is deadweight loss when there is negative externality. And I also said the key for analyzing this negative externality case is to, when you're analyzing the consumer surplus and producer surplus, you should use this social cost as the supply curve. And basically, you could completely ignore this private cost supply curve. And then you will examine two pairs of price and quantity, right? So you will examine the welfare at the market price and the market quantity. And then you will again examine the welfare at this social optimum price and social optimum quantity. And then you will find out there is this triangle H. It is the deadweight loss under this market price and the market quantity. And then I also briefly mentioned how do you correct this negative externality. Well, this picture actually gives you some hint. So what you can do here is, let's say if this is a aluminum producer's supply curve, and this producer is polluting the environment. So what you can do is, if you want to correct this negative externality, the government can impose a tax, right? So if government imposes a tax, right, exactly as the distance between these two cost curves, then you will see that the private cost curve will move up and it will overlap with the social cost supply curve. So if the size of the tax is perfectly correct, then the tax can actually remove the negative externality, at least theoretically. So the way of using tax to solve negative externality is called internalizing the externality. So in the pollution case, when you're imposing tax on the producer, then the producer will have this incentive to reduce pollution, because now pollution becomes expensive because there is this tax. So basically, internalizing the externality means you're using tax to change people's incentive and make them to consider the external effect of their actions. Once they start considering the external of their actions, their choice will actually push the equilibrium to this social optimum level. Obviously, if there are negative externalities in this world, you should expect there are positive externalities in this world, right? So if some action has some positive external effects on bystanders, then there is positive externality. A very typical example is about education, right? So through education, we will have more informed voters, right? So through education, voters maybe will believe in fewer conspiracy theories, right? So this will actually lead in better voting, which will generate a better government, better president, right? And then also through education, there could be less crime, right? Because if you have good education, then you could have a good paying job, then you will be less willing to commit a crime. So this will make everyone safer. So basically, you can see that education has positive externalities. Now, what's the implication of this positive externality? So if you draw out, right, if you use this supply and demand curve, okay, let me make this line thicker. So if you draw out this supply and demand curve with positive externality, this D is really the private benefit. So this demand curve will, let me follow the lecture note. Okay, let me just use this picture. It's much nicer. So if there is positive externality, just like the case when there are negative externalities, we will have this different, we will have two different curves. And in the negative externality case, we have the social cost curve and the private cost curve. So we have two different supply curves. And in this case, we have two different demand curves. The first demand curve, it represents private value. The second, the demand curve, which is on the right, gives you the social value. So what is private value? It's like when you're talking about private value, in the case of education, it basically means as a private person, as an individual, what is the benefit you can get from education, right? So that is the private value. What is the social value? It's the value to this person as an individual plus the external benefit to this outer world, to this society, right? So obviously, because education has positive externality, then social value should be larger than the private value. So the demand curve about the social value should be on the right? Now, what's the implication of this different curves on equilibrium quantity? Well, you can see very clearly from this picture. What you see here is the socially optimal quantity, which is determined by the cross-section of the supply curve and the social value demand curve. And this Q optimum is larger than the market quantity, right? So this basically means that first, again, the market equilibrium is inefficient. Second, it means that the quantity produced by the market is too small when there is positive externality, right? Now you might want to ask, so how can I, or what kind of policy I can use to make this market efficient? Well, you could actually use subsidy, right? Think about this. Let's say the difference between this social value and this private value is $100. Now, if you give this person $100 of subsidy, then this person's demand curve will just shift upward, right? Because of this $100 subsidy, right? So this explains why government will subsidize education through public schools and government scholarships, right? If you compare this example with the pollution case, you can see that in the pollution case, the quantity, the market equilibrium quantity is inefficiently large. It's too large. So what you would do is you will use tax to shift the supply curve to the left. And in the positive externality case, the market quantity is inefficiently small. It's too small. So you will use subsidy to move the demand curve to the right. And it's quite understandable why you're using subsidy here. Because here, well, you can basically consider subsidy as the opposite side of tax, right? So if you produce too much, you're using tax, then you definitely should use subsidy if the market is producing too small, right? Okay, so let's summarize. So negative externalities lead markets to produce a larger quantity that is socially efficient. Positive externalities lead markets to produce a smaller quantity that is socially desirable. So the government can internalize this externality by using the following two policies. If there is negative externality, you can use tax. And if there is positive externality, it can use subsidy. Okay, now let's see this quick quiz here. Can you plot the deadweight loss from positive externalities? Okay, let's see how could we plot this. So first, let's mimic the lecture. So we would actually draw out two different supply curves, right? So let's say this is the private value, private value, and this is the social value. Now, obviously, you will again get two pairs of price and quantity, right? So here, you will get the market price and the market quantity. And here, you will get the socially optimal price. So let me see what's the name for this price. Oh, we don't have the name here. So let's call this P optimum, right? So it's the optimal price. And then we have Q optimum. So it's the optimal quantity. Now, how do you find out the deadweight loss? Similar to the case when we were dealing with negative externalities. Remember that when we were dealing with negative externalities, we focused on the demand curve and the social cost supply curve. Here, you will focus on the supply curve and the social value curve. Right? So you will focus on the social value demand curve. And now I am asking you to find out the deadweight loss. You will find this is actually very easy to solve. So for the market equilibrium, we are looking at this point. Now, how could you find out the deadweight loss? Well, the deadweight loss is just given by this little triangle, right? So you can see that in this case, this is the reduction in the quantity, right? So you can see that the deadweight loss is given by the area between the supply curve and demand curve. Okay, let me give you a more detailed analysis to show you why this is the deadweight loss. So let me extend this curve, right? And now let me give some names for these. Oh no, let me give you, okay, this is a mess. So let's see, how could we find out deadweight loss. So I'll call this shape as A and B, C and D and E, right? So what you can see here is, let's compare these two different prices. So at price optimum and Q optimum, that is at this quantity and the price, the total surplus is given by A, B, C, D, E, right? Now, at the market price and market quantity, how do you find out the total surplus? Well, total surplus obviously is given by the consumer surplus and producer's surplus, right? So what is consumer's surplus here? Now let me show you what is consumer's surplus. Remember, consumer surplus is always the area between the demand curve and the price. So here, price is given by P market and demand curve is this curve. So you can see that consumer surplus is given by A plus C, right? What is the producer's surplus? Well, it's the area between the price and the supply curve. So it's given by E. And now if you compare this total surplus with this total surplus, what kind of difference you can see here? Well, you can see that the deadweight loss is given by the difference, right? It's given by, so what's the difference here? It's B and D, right? So you can see that B and D, this little green triangle gives you the deadweight loss, right? Basically, you can see that the shape of this deadweight loss is kind of similar to the deadweight loss resulting from tax, right? Well, because fundamentally, why do you have deadweight loss? It's really because this reduced quantity, right? If you compare these quantity, it's really because of this reduced quantity. As quantity reduces, right? These buyers and these sellers, if they trade with each other, they should generate some positive total surplus. However, because of this reduction in quantity, this part of the market is missing, right? So there is deadweight loss. Give an example of a negative externality and a positive externality, and explain why the market outcomes are inefficient in the presence of externalities. I mean, you could pretty much use the same example from this lecture note, right? You could talk about the pollution case as the example of negative externality, and the what's the other case? Oh, the education case as the example of positive externality. Of course, you could also think about what kind of other examples you can get from your life, which would